web. And I just want to make sure everybody knows what this event is being recorded, but if you do not wish to be included in photographs or video snippets, then you can let me, or Mehmet, or Grace, or Charlie, any of us know, and we'll help you remain anonymous. Okay, wow. Hello, everybody, and welcome to the Brighton Data Forum. It is absolutely lovely to see another roomful, another event with a room full of attendees. This is it's great to see you all. I also recognize that we have a number of new faces in the group and intermixed with the regulars. And so let me just repeat what I always say, that the Brighton Data Forum is a community of data professionals in the broadest sense of those words. We cover all aspects of data, and we have the full range of professionals in our midst. We cover data visualizations, data engineering, database management, data science, my own field, and visualizations, ethics, you name it. And it is our belief that if you work in any of the data professions, all of these data topics are of relevance to you. And so the membership counts people from the executive suite to individual contributors and leaders, to enthusiasts and students, and we especially encourage participation of those who are taking their first steps in the world of data. And so, and that's kind of what this event is all about. So, and that's what, we have a really great event for you. Oh, and I forgot to say in the very beginning, my name is Oskar Holm, and I have been organizing this event, these events, and Mehmet has been helping me a lot here with this one. So, yeah, that's my introduction. The Brighton Data Forum has its home base on meetup.com. That's where you'll find us, that's where you'll sign up. But we also have online presence on Slack. So we have this Slack workspace where we continue the conversation between events. And if you haven't already, I'd like to encourage you to join us on Slack, join the workspace, come in and see what the conversation is about. And please, when you do, join in. Send us something you find cool, or stupid, or you want to criticize, or you want to praise. The conversation continues on Slack. Now, before we get to the star event, I want to express my gratitude to all the good benefactors that the forum has. We're very lucky among the meetups here to have so many and so regular benefactors. And now, the first of all, we should acknowledge is the space that we get to enjoy. I really love having events here on the space. The door is right at the street level. You can just walk right in, and it's a nice, warm, wide environment, full of the smell of pizza and opportunity. So, so here to tell us about Barclays Ego Labs is Andy. Take it away.
Cheers, Oscar. Thanks very much. So, welcome, guys. Just a couple of things I just need to point out before we start. Toilets through the door. Follow the stairs down and just follow it right round to the left, and the toilet's just at the side. There will be no fire drill today, so you'll be pleased to know. If there was, just follow me, because I'll be out that door quicker than any of you lot, and join me at the Joker for a pint. Yeah, so that's where we go. The other thing that I just want to say is Barclays Eagle Labs loves supporting Oscar and the Brighton Data Forum. We've been doing it for years now. And this is my second year that I'm able to be here to support Oscar and you guys as well. Within Barclays Eagle Labs, yeah, as you can see probably from the side, we've got 38 sites around the country. we've actually supported 19,600 businesses last year. So that it may be through our mentoring programs, our accelerator programs, yeah, or events like this. Yeah, so we are here to support your business grow and scale. So what I would say is if anyone wants to look at the ways that I can help and support, you know, come and speak to me after when we have a chat. We also offer a bit of co-working as well. So if you want to get out of your home, don't have anywhere to go, but you actually feel like you want to do a bit of co-working, come down to the lab, come and join us. We've got a great team down here and you'll be made to feel really, really welcome. But enjoy this evening. It will be a blast.
Thank you, Andy. And yeah, give them a warm hand. Thanks to Barclays Ego Labs for their continued hospitality and grace. Speaking of grace, our benefactor, second benefactor is Silicon Brighton, Brighton tech community. Here to tell us all about it is the program manager, Grace.
Thank you. Hi, everyone. Hello again to people I already know, and a big warm welcome to people I don't, or people who haven't been to this meetup or other meetups in Brighton before. You're all very, very welcome. This is actually one of many tech meetup groups that happen across the city. There are about 30 altogether. And here at Silicon Brighton, we're a not-for-profit and we consider ourselves to be the heart and the hosts of Brighton's tech sector. So the 30 groups are all free to attend. They're available. I've been told that there is another slide coming up with these 30 groups. So they're all free to join. They're available for people at all levels. Oscar's sort of already said that actually, you know, students more than anyone, you know, really encourage you to kind of come and tell other people about this and that these are happening. And they're all live streamed as well as being in person. So the idea is that we remove as many barriers to entry as possible to be able to come to events like these and benefit from all the good stuff that happens, all the talking, all the conversations, all the potential employment opportunities, all the learning, and just meeting people and making new friends as well. So that's just a bit about that. And then in terms of the support we offer, the way that we're able to fund what we do and keep these events free is through our amazing supporters. So these are businesses who contribute to us financially on a monthly basis so that we can continue to keep doing the work that we're doing. So these are all the companies so far who financially contribute to fund the programme. And that is it from me. Back to Oscar. I think we've got a Rittman Mead slide coming up. Thanks very much.
Thank you, Grace, and thank you to Silicon Brighton. And for those of you who don't know, they what they do behind the scenes to get these events going is phenomenal. They provide all the tech and the audiovisual gear. They do promotions. They get me in touch with fantastic, great speakers to bring in front of you, and tons of moral support as well, and when times get tough. So thank you very much to Grace and the team at Silicon Brighton. Now, I hope you enjoyed the refreshments earlier before I yelled at you to come down and sit down here. I hope you enjoyed the beer and pizza. I certainly do. And I also enjoy our next sponsor, which is Rittman Mead Consulting. And they are a globally recognized and leading data and analytics company and knowledge center of all things Oracle, with global clients and lots of exciting projects. Now, some of you have mentioned to me tonight that you're open for opportunities. I would warmly recommend you contact Rittman Mead to see if they have openings, because they periodically do. They are a consulting company, and sometimes rather than having open positions, they are flexible to making new contracts when they know that they have talent in waiting. So, we have talent that can do exactly this. Maybe we can reach out for this contract and try to get that. So that comes with my recommendation. And my greatest thanks for Richmond Mead has now supported us with refreshments for 2 years, and they've just confirmed that they're continuing their support in 2024. So yay, we have beer and pizza. Excellent. So my thanks to Richmond Mead. Now, here comes a little behind the scenes. You can now you can see how well organized I am, because talk amongst yourself. This will be short. I've been doing these events for 5 years now, and I think I'm about to catch the hang of it, just not tonight. Silicon Brighton organizes a lot of events. You go to their webpage, Silicon Brighton/events, and you'll see so many events to sign up. You'll never see TV again. But I'd like to tell you about some events outside of that range as well. Coming up in March, this is an online event. It's going to be at an inopportune time for us here in Brighton, I admit. But Data Mishap Night is where speakers come and tell give short presentation about something that went wrong in their work with data. And this is the third, or I don't know. They've been doing this for a few times, and these events are absolutely marvelous. And you learn so much from other people's mistakes that it's quite useful. And for all the R people in the room, I don't think I need to introduce Hadley Wickham. He is a bit of a rock star, superstar in that world. But to the rest of you, if this is your introduction to him, you're welcome. This is absolutely worth knowing and absolutely worth seeing. All right, everybody caught that QR code and signed up, because this is an event not to be missed, even if it's going to cost you a little bit of sleep. Now, and then coming up in, sorry, that was in March 7th. Coming up in June, Pi Data in London. Lots of tutorials, lots of talks. Nigel, you've been to one of these events, and thumbs up, right? Thumbs up from Nigel, thumbs up from me. These are cool events for data professionals in the Python world. Moving on to the R world, my friend Jeremy, who runs the Brighton R and Manchester R actually as well, via DataCope, is happy to announce that the EARL conference, that is Enterprise Application in the R Language Conference, which has been an annual conference in London for many years, took a hiatus and is now back, and it's going to take place in Brighton. It's moving, and this rock star celebrity that I mentioned before, Hadley Wickham, is actually coming to Brighton to give a talk. So my recommendations again to this event. This will be in September, so you'll have some time to prepare and send in your talk suggestion, because this will be a fun one to talk at as well. Andy Fields, I believe, is the other speaker that. I wish I had memorized this, but I think it's Andy Fields. Nigel, question?
I just thought of one other conference to mention, actually. If anyone's interested, there's a conference called State of Open Con, which is on in London next week. I think it's the 6th and 7th, so it's Tuesday, Wednesday. I'm actually speaking at that conference on quantum safe security. But they offer tickets for free to students and to anyone who's between jobs. I know it costs a bit to get up to London these days in the daytime, but if anyone's interested in that conference, if you look up State of Open Con 24, it should be quite an interesting conference. So just thought I'd mention that.
Thank you, Nigel, for bringing that up. Yeah, I'm sorry, I should have had a slide for that. You sent it to our Slack space, and I didn't pick it up. But well, that tells you all you need to know. You need to join our Slack space, and you'll find there the link to OpenCon. Okay. Now, finally, it is the main attraction. And I would like to welcome, send a special welcome and regards to our online audience. Thank you for tuning in. We'll be now starting the talks. We have a fantastic event. We just put in all the groundwork, and we got 6 speakers to give you each give you a short presentation on a recent project they worked on. These are students, recent graduates, hobbyists with a project worth sharing, and we're going to start with a marvelous one. I know because I've seen in advance. And Roland, I'm going to give you the honor of starting the event. You ready? Give him a warm hand. Thank you, Roland.
Hello, everyone. Thank you. Just getting ready. Well, thank you for having me, everyone. I'm Roland. Hi, I'm here. So my presentation is going to be about who I am. So cooking up code, my database journey in Brighton. Because I'm a former chef, now working as a bus driver, and I'm a part-time coder. So I just code in my free time, basically. And that's me doing all the different stuff what I do. So first time when I started coding, that was 10 months ago, maybe 11 now. And I decided to teach myself programming. So I asked Google. He said, Python is the way to go. So I did. Then I started my journey to, writing functions, learning about things. And my first introduction to databases, because, that's what we're talking about today, it was a JSON file. And all I did is I wanted to create something to myself, a project, because I like project-based learning. So what I did, I decided that I want to create a recipe search website. And basically, the first iteration, it was a JSON file where I did key pairs with ingredients and instructions and all the exciting stuff. And I wrote a really small, basic function to do that with a few if statements, and it worked. And I was so happy. Then I continued my studies, and I met Flask. Flask is a Python library, but probably all of you know that. And it's used to basically run a website. I only got it as far as running it on my own PC, so that was all offline, but I managed to do that. And that's when I started to use SQL Alchemy to create my own very first database structure, which was a very simple one. I had a user and I had a node, and that was a one-to-many ratio, so one user could have many nodes. And I was able to delete them. I was able to use file structures first time, because up until then, I only used one Python file and I ran it from the terminal. So that was a kind of big step for me. And then I started to go to, it's a bit of a Code Bar event, which is happening in Brighton. And they are an amazing organization. And they actually have, they meet up every 2 weeks. And they do that wonderful thing when you can have one-to-one conversation with someone who is a lot more experienced than yourself, myself. And I met Philip, and Philip was a Django developer. He was my first mentor. And then I decided to learn Django and dig into all the goodness. And to be honest, first when I read about it and I read all the files, Django seemed like cheating because it's used in rapid web development and everything, but oh boy, was I wrong. So I met Django, and then I decided to switch the database what Django offers you, because Philip said he usually uses a Postgres SQL. So I put my little project aside and I started to, well, learn a little bit about Postgres and how things works around that. And well, I managed to do that. I know a little bit about it. Not a lot, but good enough to get by. And well, now I'm at the stage when I'm working on my real data structure with all the recipes, the recipe breakdown to ingredients and ratings and users. I haven't got to the users so far, so that's only the recipe what I'm trying to get together to, well, use it on my website. But well, I'm starting to feel confident that at some point I will have a working website. I didn't manage to deploy it yet, and that's a very long way to go still. But you know, little by little, with a little bit of determination, I think I'm gonna get a hang of it. And well, basically, thank you for having me, guys, because that was it. Very short and sweet.
Thank you for that, Roland. Does anybody want to ask Roland a question about this inspiring embarking on a new project? Yes, 1 second. There you go, Sid.
Where are you going with this? Where's your destination?
My destination that I would like to have my own recipe search website on the internet where everybody can access it. And I would like to be the person who maintains it and who deals with everything what I'm supposed to deal with having a website. I don't know everything what I should know about that subject at the moment, but that's why I'm learning it.
Welcome to the club, Roland, of not knowing everything. Here, we have another question.
What did you find the hardest of your sort of learning journey? Was it learning the new frameworks or just learning to code in the first place? Or
oh, that's a good question. Hardest part. I think finding out what project I want to start with, because I do a lot of things with my wife. Luckily, I'm lucky enough to have very versatile life, and finding out what project I want to go on and nudge on that, because well, that's already the third iteration. There was probably 6 more in my head, and I think the hardest part is stick to something and not have a feature creep thing. I think that's what I'm finding the hardest. I think. Thank you.
Yeah, I think that's supremely wise as well, because there's so many courses you can take and just, I want to learn this, I want to try this technology or something. But if you don't have, like you say, a concrete project, it wobbles about, doesn't it? Any other questions for Roland? Oh, Nigel.
Hi. Did you find it useful learning Flask before Django?
Yes, very useful actually. I think learning Flask and then learning Django, I didn't have to relearn. I just have to, well, now learn the documentation basically, because as I was learning Flask, I learned that you have to know the documentation. There is no way around. You have to learn it. There are some people who say it in the internet, or who I talked to, they said like, don't worry about that. But if I don't know where I went wrong, that's just wrong, I think.
As a follow-up to that, is that the path you would recommend others to take who want to learn Django, to just dip your toes in Flask first?
Definitely not. I'm a kind of person who likes to learn in a way like how do you put that? Like I'm banging my head against the wall until it breaks.
The head or the wall?
Either.
Any other questions? No? If not, please give Roland a warm hand again. Thank you. Thank you.
Thank you.
Thank you for that.
Thank you, guys.
Thank you for breaking the ice and sharing your story. Our next speaker is Andrea. I'm sorry. Yes, sorry, you are number 3. Oops. Our next speaker is Mehmet. There you go.
Are you going to manage the remote, or should I have it? So, hi everybody, this is Mehmet. I'm a senior data scientist who working around the data profession almost a decade. I have past experience for some non-profit organizations for United Nations, and also I experience with the manufacturing, banking industry. Now, I recently graduated from the University of Sussex. So I was also one of the recent graduates. So I'm gonna today present my dissertation, which I focused on these master studies of the University of Sussex. So my topic is the impact of inflation on the income inequality. So I guess everybody knows what the inflation means, because of it is a kind of heat up issue around the world. So, but I mean, to simplify it, inflation is kind of the secret thief who is stealing from your pocket or from your plate in an invisible way. So in the longer term, your purchasing power is deteriorating or diminishing. And I'm gonna also explore how this inflation is affecting the inequality around the 3 specific region or country, we call it. In the first country is US, and the another one is the United Kingdom, and the latest one, Turkey. So before starting, you will be asking why I choose these 3 countries. I choose the United States because of this is one of the advanced economy around the world. So, and there are lots of data availability for the making econometric analysis for my studies, and I thought it will be a good case study. Secondly, I choose the United Kingdom because of we are just on that there, and not because of it, but it is also one of the largest economy around Europe. I guess after the Germany, it is the biggest economy. So that's why I chose the United Kingdom. And also I chose Turkey because I'm from there. I'm just kidding. I chose Turkey because Turkey was one of the rising star of the emerging market. And it was a kind of, good country to showcase how the global macroeconomics are working in the developing economy. I think somebody is at the door. So there are 3 questions of I was investigated. So how does inflation affect income inequality in these 3 countries? And what are the other factors? What are some other mediators? How do they contribute to the income inequality beside the inflation? And what are these mechanisms, and how do they differ among these 3 countries? So I have 2 main hypotheses for the dissertation. The first one is I was assuming that inflation, as we feel in the current situation as well, leads to increase in the income inequality around all these 3 countries. I was expecting something like that. But I was unsure about how this inflation is affecting the income inequality. That's why I also added to some control variables such as unemployment, poverty, and growth. So regarding the methodology, as you saw in the subject, this study was the comparative and quantitative one. I also used some econometrics approach. But in terms of the data collection or data sources, I didn't do it myself. So there I used the secondary data. So all of the data are available in the publicly. So I use the data sets of the World Bank, OECD, IMF, or the bank data of the public available data of the central banks of the Turkey and other countries. As you see, these are my variables. The inflation is the main independent variable, and the income inequality is my main dependent variable, which you can see later. There's a Gini index I will introduce you, and also there are some other income brackets you're gonna see. And there are some other counter variables we're gonna investigate as well. And these are the 5 measures I'm investigating, starting with the descriptive statistic to the panel data analysis. I will try to analyze how this inflation is affecting income inequality around these countries. There are some limitations I just want to briefly touch. As I said previously, there are, these are all data sets are the secondary data. So, there is no chance to do the manipulate data collection or choose the sample group. So also there is also issue with the generalizability of this study because, as I said, this study focused on these 3 countries, and all these 3 countries having, the different, options. Think about the inflation is like, yeah, like it's like a passport, national passport, but each passport has its own effect in for depending on where you are from. So it is also affecting each country in a different way. And the other warning I should put, there is no causality link between the what I'm studying and what I'm showing now. So you shouldn't infer there should be causation relationship between those variables. So I'm just warning you in advance for this. So the first part was the descriptive statistics, which was I was showing how this data is sparse around these 3 countries. And simply we can call it the EDA or explanatory data analysis of the data sets we have and variables. So as you see, right lower chart, Turkey has a historically higher, inflation, especially around the 19s and 80s as well. And not only the higher inflation, it has also higher, standard deviation. But except the Turkey, inflation is mostly correlated between the UK and US. Even for Turkey, inflation is correlated until 1980s between all other countries. And obviously, Turkey is outsider in our case, as you see in this inflation rate, and it is skyrocketing in the early 90s. The other the variable I am investigating, Gini index, for if you heard it first time, it is the inequality measure. We focused on how do you calculate the inequality overall in for a single country. It's kind of mathematical equation which is calculates the inequality in a numerical way. So when I checked the Gini coefficient all these 3 countries, historical averages are almost aligned, as you can see the mean and median numbers from the right upper side. So these 3 countries are mostly showing a similar pattern for each other. But UK has a lower standard deviation, so which means there is lower variance, lower change in terms of the score of the coefficient of the Gini in the longer term. And obviously we can see, now inequality or wealth inequality is higher than 1970s thanks to some certain macroeconomics. And obviously we can also see that there is some dispersion between the US and Turkey, and also UK has some kind of different track between these 2 countries. And another unconventional thing, and UK has a modest improvement since early 2000s, as you can see in the right lower chart, and it's becoming a lower after the early 2000s. I also ran some correlation analysis to see how the inflation is related with the all these variables. I just put the 21 4 months lag to see the implication of these policies and how those policies affected the Gini index or inequality in a longer term. That's why for to conduct the time series analysis, you need to have this kind of lag. It could be 6 months or 12 months or 24 months as I used. And there are a few points I want to highlight in here. As you've seen, and you can just see in the red box and with the asterisks, Gini index and poverty gap for Turkey. There is a huge correlation between the inflation. So if the inflation increases, so there's certainly inequality and poverty increases in Turkey. This is the initial inspection when I checked this data. But for the US and UK, it doesn't look same. So this is something we need to investigate in our dissertation, because it looks like inflation is kind of uncorrelated with the, not uncorrelated, but negatively correlated with the income disparity around US and UK. I know it sounds very unconventional, but I think we're gonna investigate why it is. So I just have a quick regression analysis with the inflation and other inequality variables like Gini index or top 1%, top 10% wealth. But I couldn't find any quite useful thing for all these countries. Even highest R square value was the 0.34, which is and also other variables are not statistically significant. So that's why I just wanted to add the other control variables to see how those other variables are affecting the income inequality. So when I add to the control variables, I just checked all other three countries, and I can see all these three countries having a different reflections of the inflation has a different reflections on all these three countries. For example, for Turkey, GDP growth doesn't have any effect of the income disparity on this country. So if you are a policymaker in this country, you need to consider that GDP growth doesn't much have effect on the income distribution on the Turkey. But inflation and poverty rate and unemployment has a certain effect, and there are statistically significant effects on the income inequality in the Turkey. What about the US? For the US, it is weird, but inflation and unemployment doesn't look have any certain or statistically significant effect. But rather than inflation, GDP growth or poverty has certain effects of the income inequality. And it is also similar to UK, but with a single difference. Inflation is affecting the income inequality in UK. Still, we don't know is in a negative way or positive way, but also unemployment and poverty rate is affecting. But in here also GDP growth or unemployment doesn't make sense for the calculations for the income inequality. I also put some other econometric insights about how income. Is there any further investigation we need to conduct? And in a general I just found inflation and GDP growth has a minor impact on the income inequality, but unemployment rate and poverty rate have a significant effect all these three countries. So if the major policymakers, they should focus on this size rather than just only inflation rate or GDP growth. Also, there are some issues with the, as you see, heteroscedasticity, which is a very difficult term to pronounce. So it also shows that we need to conduct some, sensitivity analysis on the, further, to make this research further basis. But since due to some, limitations on the, time and resources, I just didn't conduct this, part. And also we can observe that there's a normal distribution if you check the Q plot on the right upper side, but in the tail side offers some outliers that are available. So just to tidy up, there's some cross-country impact. For Turkey, higher inflation means that there's a higher income inequality as we expected. It's also hit hard in the bottom 50%, so it makes things hard for the bottom 50%. And it's also consistent with the previous academic research. So we don't have any surprise result for Turkey. For the US, there is Gini index is not a quite good indicator to measure the income inequality, but there is different effects of the top 1% or different income brackets. We need to check the different income brackets to see. And inequality is a kind of more, differentiated in the specific income groups. And for UK, it's you can call it inflation products, but higher inflation benefit the lower income groups, such as bottom 50% wealth holders. And there's also negative relationship between the inflation and income inequality. I found also very unconventional, but it is also consistent with the previous research on the UK economy and its relationship between the income and inflation, income inequality and inflation. So summary, as you see, inflation has a very different and complicated relationship between the wealth redistribution and overall income inequality. So for the case of the Turkey, inflation was found to increase the income inequality. But for the UK and US, inflation kind of reduced the inequality in somehow because of its redistributive effect. I know it sounds also very unconventional, but I mean, this is something, the output of this, I mean, research. And also, all of these three countries, inflation has a greater impact on the top 1% and 10% compared to the rest of the population, which is, I mean, if you have any question, we can discuss later. But I mean, this is also very interesting takeaway. And as a summary, inflation makes, I mean, increasing the inequality in some contexts, in some geographies or some countries, but it also offers the redistributive effects in some other countries. Also, before ending to this, I mean, research presentation, these no need to say, but these results are not applied universally because, as I said previously, we need to focus on the specific region or different economic settings. And also, I mean, as the famous say, the regression method doesn't conform causality, so the correlation doesn't mean any, I mean, causality relationship between those variables. So you need to bear in mind. So this is my, I mean, presentation. I think, yeah, I think we need to, I mean, fight against the inflation. So, but I mean, we need to also consider how to keep in the income inequality as a big concern. And I hope, I mean, you will having, I mean, good insights and also questions. Thank you, everybody.
Hello, thank you, Mehmet. Any questions for Mehmet on this? Yes. I'll go here.
So are you saying in the UK that trickle-down economics works?
Oh, that doesn't mean something. I mean, actually, I was trying to focus on the data, I mean, management of this study, but there is also some policy implications of this study which needs to be focused on yeah. I mean, this research totally disagree with the stand of the trickle-down economics. Because what trickle-down economics, I mean, whatever, I mean, there is an increase of the top 1% and 10%. I mean, it will be also, I mean, beneficial for the rest of the population. But actually, in the details of this study, I was, I mean, trying to digging up, and the mainstream approach to economics, like the Phillips curve and other I mean, mainstream approach, are actually not working in the current terms. So actually, I was going to criticize this approach by taking stance on the heterodox approach. Probably numbers are not aligned up, or I mean, you are not feeling in the same way. But just think about it, like, I mean, most of the UK wealth is held in the real estate industry or stock market. So whenever there is a huge inflation increases, the interest rates are also following these increases. So whenever interest rates are increased, also there will be, I mean, not collapse, but huge decrease on the real estate market, and also stock market is going to in a flat way or going in the bear market. So I guess this is one of the simplistic explanation of why, I mean, there is, I mean, the income gap is not widening, but also narrowing in the case of the UK. But to be honest, yeah, I'm totally, I mean, disagree. I mean, this is not a proving of the trickle-down economics. Actually, this is a very, I mean, takes a harsh stance against the trickle-down economics or other theories of the so-called Chicago boys. Thank you.
And the next question. Oh yeah, here you go.
Thank you. When did your data go until? Because people probably, at the current stance in the UK, probably disagree with what you're saying in terms of the income inequality relationship. So how recent does that study go for, or what's the time span on your study?
Yeah, this all these variables are, I mean, this is the issue we need to deal, because I mean, the oldest data we have is going back to 1955. And it varies for the different variables. For example, for Gini index, we have a reliable data since 1970s, mid 1970s. So this is something, yeah, I mean, quite new data, but yeah, I mean, this is also explain the situation. I mean, why the people are, I mean, feeling different way. We included the historical data and on all this, I mean, findings are affected by the historical averages. So, and as I said, I mean, previously, I mean, this relationship, okay, it comes with something, it inferring, okay, the higher inflation might be causing or might be related with the, I mean, a lower income inequality, but it doesn't mean it caused the lower income inequality. So, I mean, there is no causal relationship between them. Thank you.
Yeah, sorry, as well. So how recent do you come to in terms of like to present day?
Oh, it comes to 2022 to until, yeah, I mean, until, I mean, except last year we have the, I mean, up-to-date data.
All right. In the interest of time, I think we need to move on, but please give Mehmet a warm hand. Thank you. And now, Andrea, sorry. Thank you.
Cheers, thank you. Okay. Oh, okay. This works. Okay. Hello, everyone. My name is Andrea. I am a senior statistician officer at the Home Office, and today I'll be talking about time series analysis. This presentation covers my master dissertation in data analytics and is based on a project proposed by Thilo and Oscar, actually. And Thilo is a gift card platform, and they were interested in understanding and predicting sales value on the platform. So the four main goals of the project were, number one, to be able to forecast the next 3 months of sales value with an acceptable level of accuracy. The second goal was to identify a possible best model for future applications. And goal number three was to measure the impact of promotions on sales. And the last goal was to sort of explore the characteristics that successful promotions had. Okay, we can start with the forecasting side. So the data available for the project were 4 years of weekly British pound sales value from 56 different gift card sellers. And I also had demi-variables representing the absence or presence of promotions. And I also use UK weekly new COVID debt for the modeling. In this project, I've used 6 different type of models. I've used sort of modern, really recent machine learning algorithms like XGBoost and GLMNet, but also some more classic approaches, machine learning algorithm approaches like support vector machine and random forest. All of these are generic machine learning methods, and they are not sort of made or developed specifically for time series. And then I also use Prophet, which is an algorithm recently developed by Facebook, specifically made for time series. And the last type of model was an ensemble weighting model. So basically it ensemble all the other models together by creating one single output based on their accuracy. Okay, this is going to be the only intense slide, I promise you. But I felt like it was worth sharing the code with you, because one of the biggest challenge of the project was scalability. So we had 56 different sellers and 6 different models. So that meant at least 300 different models and algorithms to be run. And it was a big challenge. So I feel that it's valuable to see how this was achieved in practice. So in the first box, the preparing the recipe part, which recipe is the actual name of the function in R. And also all of this was done in the model time environment. So in the first box, simply I prepare variables to be input into the machine learning algorithms. Because as I mentioned earlier, some of them were not specifically done or developed for univariate time series.
but for, I don't know, for example, classification. So they need a large number of variables to work well. So in the first box there, I specify, I extract from the date variable a large number of variables, for example, number of the month, quarter, year, or also a step Fourier that creates a Fourier series in order to capture seasonality. Then the second box, in the second box, I specify the models, and I only put 2 just to give you an example on how the environment works. So the top one is XGBoost, which was one of the machine learning methods. And as you can see there, I only specified that I wanted a regression model, and the engine to build this model needed to be XGBoost. Then I added, so I fed the recipe into the model, and I fit the model into the data. And that was done the exact same way for every other machine learning algorithm. And it can be replicated simply by changing the engine, and even more to even to further models that were not in the ones in the previous slides. And the second example is Prophet. And in this case, again, because we're talking about a time series model, or algorithm, I only needed to specify my function or my regression at the bottom. So there you can see that I fit sales, so what I wanted to predict, with my date variable, with COVID, with the COVID variable, and with promo. And that would have been done in the exact same way if I wanted to use, for example, ARIMA or ETS or any other time series model. Then in my third box, I calculated the accuracy. So in the model time, in the model timetable, I put together all the models that were specified, and then I tested them on my test set of the time series, and then I calculated the accuracy. And then in my final box, simply I recalibrated my table using the entire length of the data, and I used this to actually forecast my future values. Okay, and these are the accuracy scored on the test set. Actually, there were 2 different test sets. The old one, which was in the original data, and the new one. The new one because Oscar wanted to test the models, so he sent me the latest available data that they had over Christmas to sort of like, again, test how well the model performed on unseen data. And obviously that meant that over the Christmas period, the variability of the data, the volatility is much higher, obviously, because it's Christmas, so it's Black Friday, so people spend more. And on the right-hand side, we can see the accuracy table. So you can see that for each model, we have the score on the old and the new test set, and we have the median MAPE, and MAPE is just a measure for accuracy, so it's a mean absolute percentage error. Then we have the mean MAPE, then the top model, which simply indicates out of the 56 sellers, how often did each model scored the best accuracy. And then simply a rank based on the mean absolute percentage error. And there were 2 things worth highlighting here. The first one is the performance of the ensemble weighted. So as you can see, the ensemble weighted was first in the old training test set and second in the new test set, and scored really good accuracy in both of them. So this shows that it is a really sort of reliable and accurate way of forecasting. And the second thing to highlight is profit. So as you can see, Prophet did pretty bad in the old test set. In fact, it's only like 5 out of 6, so the second worst. And he only scored the best accuracy 4 times. But then in the new test set, he ranked first and was the best model 35 times out of 56, which is much more than 50%. And therefore, Prophet showed to be like superior when modeling, when forecasting over periods of high volumes or volatility. Okay, now we can look at promotions on the promotion side. So I wanted to give you a visual example on how the methodology worked. So on the red line are some sales value. They're artificial. They're like, it's made up numbers. They're not real. And the dotted line are some promotions. So a dummy that represents the presence of a promotion. And how this worked was by forecasting two different futures. One future with two future scenarios. One future with a promotion and one future without a promotion. So as you can see in the top plot, the blue line is my forecast. And in the bottom plot, the yellow line is my forecast. But as you can see that there is a green, sort of bluish dotted line that represents the presence of a promotion. We can overlap the two, and we can see that they are really, really similar, with the only difference being obviously the spike when the promotion was present. And obviously, these two lines were produced using the exact same models, the exact same data, exact same variables, with the only difference being the promotion. Therefore, we can attribute the uplift to the promotion. So how was this done in practice? For each seller, only the sellers that were forecasted at least with a 40% accuracy were selected. Obviously, to exclude sellers that were like, I don't know, behaving in a really odd or erratic way. And also for each seller, an average of all models that lied within 5% of the best model were selected. And on the right side, you can see the distribution of the percentage increase. So as you can see, in 15 cases, for 15 sellers, the uplift was in between 0 and 1%, so really low. And only in 9 cases, the uplift was 10% or bigger. Okay, so now just quickly we can have a look at some characteristics that successful promotions had compared to not successful promotions. Where successful is a promotion that had an uplift of at least 3%. So on the right-hand side, the box plot on the right-hand side is the duration of the promotions, and on the left-hand side is the number of promotions run by the sellers. The red box is the no effect, and the green box is the positive effect. And also you have the values in the bottom right table. As you can see here, the duration is almost identical. So there is no absolute difference in between successful and not successful promotions in terms of duration. But if you look at the number of promotions that were run by the sellers, you can see that the median number is 3 times bigger and the mean number is more than twice bigger. So this means that the sellers that experience sort of a significant uplift run a lot more promotions. Thank you so much.
Thank you, Andrea. Thank you. Thank you for this work, and thank you for the presentation. Now, does anybody have a question to Andrea? A quick one. If not, I might drop one in here. Oh, sorry. Oh, sorry. Sorry, Ben. Here you go.
Hey, great presentation. I was just wondering, what would you have done differently, or what could you have incorporated to make the model stronger, if you were to, do it again? Or
okay, in terms of models, obviously, as the accuracy table showed, the ensemble weighted is a really powerful way to forecast, because basically it's a way to cancel out the error that the different models make. So I would say one easy way and quick way to improve the accuracy is by adding new models. So for example, obviously the running time gets bigger, but adding, for example, an ARIMA model or ARIMA boosted model, even if that model is not the best, still it can increase the accuracy of the weighted model. And what I would have done different overall, well, obviously there were some time constraints, but in terms of the promotions, obviously they were represented by dummies, so not by the actual percentage promotion. And if you think about it, even let's say you have a 50% discount, you might sell twice as many products, but the value remains exactly the same. So obviously this is not captured by dummies. So that is something that can be explored.
Okay, right. Thank you. So again, in the interest of time, we'll move on to the next one. Please give Andrea a warm hand.
Thank you.
Thank you. And I will add on a personal note, if you're a company out there, we at Tillo, we reached out to University of Brighton, and we had a project. We had something that we wanted to look into. We'd never looked into. We just didn't have the bandwidth for it. And this project wasn't in the critical path for Tillo. And we got in touch with Alexei, Andrea's supervisor, and he introduced us to Andrea, and that's how we set up this collaboration. And I just want to say that from the perspective of Tillo, this was an absolute success, and I would just encourage you who are in companies, who are working, to reach out. There are obviously offices at University of Sussex and University of Brighton, directly trying to find links between academia and the industry. And you just saw one of the success stories of what that kind of collaboration can bring. And so I encourage you to explore that for your organization. You have a project that is not in the critical path of the organization. You don't have time to devote to it. You'd love to dig into it, but even better, you'd love to have somebody come in who is curious and engaged, and and who needs to get a thesis out of this. So that's my personal recommendation on top of your talk. So thank you very much, Andrea.
Thank you.
And next speaker is Chinadu Mazi. Hello, thank you so much for coming.
Thank you for the opportunity. My name is sorry.
Just check the cable.
So, okay. Cool. Nobody's touched anything. We're good. Okay. All right. Thank you. So, thank you once again. My presentation is on my project topic from my university, which is University of Sussex, which says robust real-time anomaly detection in customer email transaction, adopting natural language processing and machine learning. If I may say, how would you feel you wake up one morning, you don't see your money in your account again? That means it has been taken by someone. So to this, the introduction is just talking all about, it's just talking about an investigation that has been done by FBI, which is relative to fraud. And this has been an issue for a long time. Even before I came to UK for study, I was thinking that in the white world, there's nothing like fraud. But from my study, I discovered that we have a high number of fraud, which also what affects every other thing that happened here. So my motivation here basically talks about the comparing of the traditional system of fraud detection, which involves using cumbersome data. And also you talk about using a traditional method, which you have traditional methods, which you have this traditional method in detection of what fraud. But in my own context of work, like I said, that my motivation is pointing towards using NLP and machine learning together as a model or as a technique to be able to detect fraud. But actually, before today, you can see that the numbers of variables which you have been able to use is up to 28 variables or even more higher than that. But this, we are looking at the conversation, email conversation of customer and the owner of business, how it can be able to, how you can be able to detect fraud from it, and which talks about the contextual meaning of of the email transaction. So to this, when you go further, now understand that the objective, this is my objective, which I undertook. There are about 5 objectives of them. So the first one was to build the model, evaluate and compare the difference between NLP models such as word-to-vector and TF-ID vectorization to determine the most suitable of them. So what I did here was, first, I initially took BAT as a model, but because of the time frame of our project, which is just 3 months, I now bring it down to using word-to-vector and TF-ID. So when you now go further again, I also built what the second objective is building machine learning model for classification of vectorized word into anomaly and normal. Apply metrics like F1 score, precision, ROC and AC, and accuracy. All these things are just the metric which I use to be able to determine the to be able to evaluate the metrics. Then the third one is investigating whether there is any change in fraud behavior over time. So going forward, this is a literature which I will be able to I studied that gave me the idea of implementing this. This is actually my model. I actually got my data sets from Kaggle, and first I sourced the data and collected it, clean it. In the process of cleaning, I was able to remove all punctuations, also remove what's it called? Remove I was able to remove punctuations. Then further, I did what we call feature selection. In this feature selection, what I was able to do is just collect relevant variables, taking away unrelevant variables. Then you now go further by doing text preparation, which is part of it, and feature engineering. Then I was able to combine the unsupervised learning and supervised learning together. Then what I did was using this JSON pre-trained large model couple to do what we call classification of them. That's classify the text, classify each of the emails into normal and anomaly. So what I did there was that I picked up an NLP model, which is the word-to-vector and the isolation forest, to classify this text into normal and anomaly, which I represented the normal as 1 and the anomaly as -1. Then now further go by doing a supervised learning approach again, where you have your TF-ID, where I have my TF-ID and word-to-vector. So I was just trying to compare these two techniques of NLP and see how it's going to give me a very positive outcome. And I'll move forward by using 2 classifiers, which is random forest and decision tree. Then the one classifier, which is isolation forest, and one classifier SMV. Then it was then able to identify that, we have anomaly text, and also a normal text. Then from the data set collected, there was a huge amount of imbalance. So for me to be able to balance this data, I use Smoothie, which helped me to be able to balance this data set to have a 50% of the stuff. So we now have a feature selection, contextual data transformation. This is now where you now understand the different approach of data of word representation, difference between the word word to vector and word to vector and TF-ID, how they are being differentiated, or how they are being, or how they represent data or represent words anomaly in anomaly detection. Because of time, then with this now I was able to do a comparative analysis on the NLP and machine learning models. When you look at the analysis, when you look at this result here, is a comparing of these MLP models and NLP techniques. Then I will now say that using the macro average, which is the outcome, micro average, now say the score when it's necessary to treat all classes equal in order to assess the classifier over or to perform against the prevalent label class. So when I did this, and I discovered that you know that in a context, whenever you want, you are trying to use a metric, the metric like accuracy now is not good for an imbalanced data. It's not good for an imbalanced data at all. So what I did was that I was able to get the outcome from an imbalanced data and also get an outcome also from what? A balanced data. And from the context, from the first one, it shows that random forest performed well. But from my own observation as a human, I was thinking that because of the process of my, because of the whole process applied in my analysis, I was thinking that it would be isolation forest, because that was the first model. That was the model I used in unsupervised learning to be able to classify them into anomaly and normally. Then when you now go further, you now see that the random forest and the walked vector was able to perform well. Then going ahead, you also have, because we have looked at this, it gave us a very good outcome. This suggests a very good overall performance of random forest with TF-ID. And also, you check that from the word to vector also, it performed well. But we do not stop, I do not stop here in the analysis. Then I now move further by also doing using another metric, which is ROC, that's RUC, AUC. I was able to use it to confirm what I have been able to get in the previous analysis. And with this, you now be able to show clearly that random forests together, combining random forest and word to vector, was able to give us a very positive outcome. So with this, after every analysis, I was able to build my model. This model I was able to build, I use it now to implement a system that can be able to implement a system that can be able to determine the level of risk an email transaction could have. In this place, I was able to have an inbox and outbox. In this inbox and outbox, it's where a user can be able to send a transactional email. That's an interaction between customer and the seller, or let me say between the buyer and the seller. So in the process of their email transaction, it cannot be able to show that, yes, of a truth, that this email or the interaction is anomaly detected, and also tell you the level of the risk which is applicable. So in conclusion, the aim of the project to develop a robust and effective anomaly detection system that leverage NLP model to detect suspicious or fraud customer interaction via email or real time was achieved, helping to safeguard the financial integrity and security of the organization. The NLP model, which is this, which is TF-ID and word to vector, we are compared based on the contextual data sets. The word to vector techniques are adopted based on the method of the word representation, dense vector, and identify the semantic relationship between it. So why, even from the theoretical concept or from the theoretical view, you understand that word to vector in its own representation is it shows the semantic relationship between two words in a sentence or in a context. So to this, in all the models actually perform well from the analysis I did, but the random forest and word to vector outperform other models with a metric value of F1 score of 86%, precision of 0.8, then recall of 0.93, and accuracy of 997. When you look at the literature, from the literature which I got this motivation of my project work, it said that the accuracy was 80%. But with this, I can see that my system was able to do something more positive than that. So the two models was NLP and machine learning was used to implement a robust real-time customer textual interaction system. So with this, thank you very much.
Thank you, Chinedu. And does anybody have questions? Yes, please. Thank you.
Where did the data come from?
Kegal.
Oh, was it a competition or a publicly available data set?
It's not a competition. Oh, sorry, it's not a competition. It's just an open data which I saw. There was no proper implementation. Actually, nothing was done. So I now pick it up as a project topic.
Did you identify any terms or tokens or that were highly associative of fraud, or is it only in the combination that the signal was found?
It's not clear. The question.
Sorry, any terms in the term in TF, IDF, or any particular tokens in the word2vec methods that were highly associative with fraud?
Yeah.
That you should keep an eye out.
Yeah, one thing you need to understand about this two model is the ability to identify semantic meanings between texts. So there was a clear analytical process which was identified. Okay.
Yeah.
Hey, what was the method that you used to create an even distribution of spam to non-spam emails? I missed the name. Was it bootstrapping, or did you? Because
there was.
I don't know if you said you increased the samples of the spam, the amount of spam emails in the data set.
No,
I don't know
no,
if you used permutation or bootstrapping or something.
No, there was not such.
Yeah, it was a smote, wasn't it? Yeah. Yeah, synthetic minority over something. Any other questions? No? Then thank you to Chinedu, please. One hand. And our next speaker is Felipe. Felipe, just take it away. Woohoo! Yes, indeed.
Thank you very much for the invitation. First, I will introduce myself. My name is Felipe Martin. My background is electrical engineer, but I became to data analyst, and I've been working in that for 7 years. Sorry. I finished my master in data science at Sussex last September, and this is the project that I will be talking about today. And I have this is a consulting, datadecisionlab.com, where I work doing this kind of dashboards or data visualization solution for different business. For instance, something like that. or something like that. It's data visualization solution for take decisions, for help companies take decisions. Okay, about the project, first we have to imagine an observer who is looking visual stimuli in, for instance, first 0 degrees, 90 degrees, 180 degrees. And he's looking this visual stimuli during a period of time. The observer is in front of a screen, or a screen like that. At the same time, we are measuring the neural activity of the observer. We can see the peaks of each neuron. And one of the objectives of the project is create a machine learning model to predict what is the visual stimuli that the observer is looking at. Now we have a second scenario with the same observer, but now he's in arousal state. We make the observer he runs, or he makes some task. So he's in arousal state or in alert, in alerted state, but he is looking the same visual stimuli. We are measuring the same neural activity from the brain of the observer, and we create a machine learning model to predict what is the visual stimuli that the observer is looking at. Okay, sorry. Now the mainly question of the project is which model better predict visual stimuli? The model with the data from the observer in arousal state, or the model with data in non-arousal state? This is the main question. And a big why, because we want to understand what is happening in the neurons of the observer or in the brain, that one of these two models is better than the other. And we are measuring the accuracy of the model. This project has two big parts. One is about data visualization and analysis, and the second part is about machine learning. The data, first we have to collect the data, and it was collected from measurements of neural activity in mice while viewing lines at different angles in a screen in front of the mouse. And we use a method, it's called calcium imaging. It's an optical method to obtain image from the neural activity. And to know if the mouse is in arousal or non-arousal state, we use the pupil size of the mouse. If he has a huge pupil size, it means arousal. A small pupil size means non-arousal. This is how the neural activity looks like. It is flashes, like flashes. And brighter flashes means activation of the neuron. And if we translate this neural activity into data, it will look like that, where peaks of the, we can see in this graph, some peaks. And these peaks means the activation of the neuron. And in the image, it will be it is a flash, a brighter flash. But we are working with more than one neuron, several neurons. So it will look like that. We have one graph for each neuron, and we can see the peaks for each neuron. The data set size we work, it was 23 experiments from 2015 until 2017. It was 150 million records before data cleaning, but after a process, data cleaning process, we obtained just 19 million records. This is a data visualization solution to understand how is the behavior of each neuron. In this image, each circle is a neuron. So if I select one of the neurons, I can see the neural activity here in the graph. And for example, if I select one neuron, I can see for each peak, a number over the peak For instance, in this case, I can see 270. This is a visual stimuli that the observer is looking at in this peak. And I can see 270 is repeated. I see 270, 270 in almost all the peaks of the neural activity. And if I made another graph with the average of neural activity in the axis Y and the visual stimuli in the axis X, I obtain a graph like that. And I can see here the peak in 270. This is one neuron. This is other neuron. And I have a similar behavior, but in this case, the observer is looking 90 degrees. The peaks of the neural activity are at 90 degrees. And this is other neuron, but in this case, the peaks of the neural activity are at 240 degrees. So I found a pattern. This is a pattern in my data. And this is called selectivity of neuron because some neurons are activated to some specific degrees in the visual stimuli. Some neurons are activated at 90 degrees, other at 240 degrees. So I can say that the neural behavior can be explained by the visual stimuli that the observer is looking at. And now, can we do the reverse process? This is from the neural activity. Can we obtain the visual stimuli that the observer is looking at? And the answer is yes, with a machine learning model. This is a multidimensional problem because we have several neurons and each neuron has a different measure. And if we sort all the measures in this way, in a specific time, I will have different values for each neuron. And these different values will have associated visual stimuli. In the first case is 30 degrees. The second case is 90 degrees. And all these different values for each neuron will be my features in my model. And the visual stimuli will be the classes. To solve the problem, I use supervector machine because this method is especially good to multidimensional problems. And in this case, the dimension of the problem will be the number of neurons. If I have for instance, if I have 250 neurons, the dimension of my model will be 250. The results of the model, we obtain an overall result. We obtain a good accuracy, over 80% in 14 out of 23 experiments, except in some experiment. For instance, experiment 15, we obtain a low accuracy. But this is because there is a high correlation between accuracy and the number of neurons. So if I have a low number of neurons, the accuracy will be lower. This is a graph that shows the accuracy versus number of neurons. I can see the correlation experiment 50 if in the bottom of the graph. And when we make the separation between arousal and non-arousal state, we find that the majority of the experiment model classifies better in arousal state when the observer is in alert. So yeah, if an observer is in arousal state, if we made a predictive model to predict what he is looking at from the neural activity, the accuracy will be better in this state, in arousal state. This can be explained because when we are in arousal, sometimes the body fight or flight response is activated, so we can focus better in what we are looking at. This is the project. Sorry. If someone wants to know more info, I have a blog in this web, datadecisionlab.com, and my email is info@datadecisionlab.com. Thank you very much.
Wow. Thank you for that. Now, does anybody have a quick question for Felipe? Oh, yeah.
What software did you use for the visualization? Because it's quite interactive, isn't it?
Oh yeah, this is called Power BI. It's a software especially it's more especially for business, but I use this for this kind of a statistical.
Oh, just plain Power BI.
Power
That's
BI.
quite impressive actually, because it looks quite smooth. Usually it starts slowing down when you start clicking about.
Oh yeah. I focus a lot in the design of the dashboard with the gradient.
Yeah, I was just wondering why you created a binary arousal, non-arousal when you had a nice continuous variable of pupil size. Did that do anything? Did it give you any insights? Did you think about just using pupil size as a continuous variable?
I separate the data. I make a model separated, one for arousal state, another model for non-arousal state. So I made the separation.
Yeah. How did you decide where the threshold was? And
For the pupil size?
Yes.
I use I remember I used I plot the data, and I use the median of the pupil size. So I use over the median is, I don't remember, but I use the median to a parameter.
More question for Felipe? Yeah, let's go for it.
Did you ever try and run the prediction of the arousal model on the non-arousal data to see if it was able to predict? Because there must be some commonality with, as the input's the same.
Sorry, what is the question?
Does that make sense, that question? As in, like, did you ever run the model that was trained on the arousal data? Did you ever try that model to predict on the non-arousal data to see?
Yeah. I made a sorry. I made a analysis. It's called cross analysis. So I made a combination between arousal data, non-arousal data, arousal data with all data, non-arousal data with arousal data, and all the combination, all the possible combination. And I found that when I train in arousal data and I test in non-arousal data, and when I train in non-arousal data and test in arousal data, this is the lowest values of all the other combination. And this means there are significant difference between these two states. So the neural behavior is different in these two states.
Thank you for the question. There was another up here.
Where can this be used sort of like in real life? Let's say that like, oh, your models are like spawn, you get, I don't know, 95% accuracy. Like, how can this be used, or for what?
The answer for that is this model is not for use in practical ways. It's more research for, we have an hypothesis, and this hypothesis is that people who is in arousal state or in alerts can focus better in some objective. And we want to compromise this hypothesis. And with this model, we compromise this, but it's not like a practical for.
Well, you can say now that, oh, you need to be in arousal data and you will focus better. So that's a practical, like, so yeah.
Yeah, don't sell yourself short. I'm sure Elon Musk's Neuralink would be interested in this. You should give him a call.
Yeah, kind of like you made an allusion that adrenaline kind of make you focus better, like the flight, and yeah, but then could it also be that it's specific targets, like you're more focused on one thing, not seeing everything around you, which is way of escape in times of flight? And then I'm also thinking about it, could it also be one of the reasons why when you procrastinate, and then the arousal could also be like your deadline, the panic, and then the insight comes in. Maybe there are some significance to your model as well. Yeah.
Thanks. Yeah.
Right. Thank you. Thank you all for your questions as well. And give Felipe a warm hand again. We have one last speaker for you, and then it's off to the bar. The only thing stopping you from getting to the pub right now is this presentation by Abhishek. And yeah, with that introduction, go ahead. Thank you.
Hi, everyone. Good evening. So my name is Abhishek. I am a MSc Data Science student in University of Sussex. And here I am to tell you about DevOps. So in my last organization, when I was working on a project where I implemented DevOps in big data using only one click. So how I implemented one-click deployment in big data project. So I know most of us know what is DevOps. So these 4 keywords are the most important things, like continuous integration, continuous deployment, continuous testing, and continuous monitoring. So this is the base of DevOps. But in waterfall model, what was followed earlier, it was not continuous. So because of this, the performance of the deployment or the frequency of deployment increases like hell when it goes to production. So this implicitly benefits the organization. So how frequently move into the production. So some of the CI/CD key tools which I have used in my project are like Jenkins, GitLab. I think GitLab most of us know. So it's like GitHub. If people have not used GitLab, so it's like GitHub. And SonarQube, it does a code quality check. Nexus IQ server, I think this may be new for you. So it checks the jar. What is the vulnerability of the jar? If any jar you are using in a code, what is the vulnerability? So every organization has different standards. So what they go for the standards. So if they allow that level 1, 2, 3, 4, 5. So level 5 is like the least, is the most vulnerable. So we should not be using this type of jars in our code. So this Nexus IQ server evaluates the jar. Okay. Then now coming to Nexus repository. So it is used to store the artifacts. Because whatever is being deployed in the production, we can store it ultimately, because that's the final code which is there in the production. And this is the complete design which I made to do the one-click deployment. So as you can see, the Jenkins list sits in the mid. So it's a driving tool, and on the Jenkins only, every other tool is integrated, like Git, SonarQube, Nexus IQ server, and Ansible. So you can see the three parts, because in the development environment, whenever any code is developed, it will use all 4 tools which you can see, and because the code quality will happen in the development environment, right? And when it is approved and your jar is fine and it's not vulnerable, it should move to the test environment. And ultimately, once everything is stable and tested properly, then ultimately it should move to a production environment with Nexus at the last, because you need to save the artifacts what has been deployed finally into the production. So how the main thing is how I achieved one-click deployment. So this was the sample of the code which I developed. So the Jenkins file, if I keep it in Git and I integrate in the Jenkins with the Git, right? So once I commit it from the Git side, I can automatically trigger the job in Jenkins. So let's suppose if I commit it today, and the commit happened and the job runs at 12 a.m. in the morning, so automatically I don't need to do anything, because already I have committed it here. So with a one-click with a one-click here, I can deploy my code in production. Okay. So this is a folder structure. I can't go more detail because it's like so much of code. But just tell you that the Jenkins files is the main here. Is the soul through which I am connecting with all the tools. So it's like you can say like through single files I'm connected to your Nexus IQ server, to Ansible, and to your SonarQube. So everything is happening from Jenkins file. Okay, so I will show you a little bit of code of Jenkins file, how we write a stage, and in the same way you have to write other stage if you want to implement it in your solution. And so this is the rollback and forward script which I want to show you, because when one-click deployment happens, and let's suppose it happens at 12 p.m. night, 12 night, so it should be able to roll back if something fails in the my forward script. So the code also handles the automated rollback, so that my system, if something is deployed in production, it should come back to the normal state, what it was earlier. So for that, this how we integrate Git with the Jenkins. So you can see the repository URL. So this nothing is the URL where my code sits along with the Jenkins files, and this branch specified is nothing is my branch name. And now one more question comes into mind: how will tackle the user key and password? Because every tool has a user key and password, and it should be secure enough, and it should not be visible anywhere, right? So we have a credential container in Jenkins where we can create our credentials, and in this way we can store the username and password. So once you store the username password, there is an ID. You can see CAD underscore ACC. So this CAD ACC underscore ACC ID we can use in anywhere in our code, and we can use the corresponding hidden username and password. So this is the config file, which is just a sample to show you how it works actually. So you can see Jenkins key tab ID is just CAD underscore ACCT, which I showed you here. So using that, I will use it as a username password in my code, and no one can see it. Okay, and the forward script and rollback script which I showed you also needs to be mentioned here, so that it can be used to do your implementation. And if anything goes wrong, then it will use a rollback automatically. Okay. And this is just a sample how deployment, how a simple table is created in big data. So you can see K in it. So just think it's like it's a Kerberos authentication which needs to be done before anything gets deployed into the production. And just how a table can be created using a beeline. So it's running on a Unix server. It's running a Unix server. If anything fails, then I have a corresponding rollback script which is dropping this table. Just a simple example for you. Okay. So in that way, you can add your more steps. Which whatever you want to do, it's a file. So I have given a liberty to the developers. Whatever they want to add, they can add. Okay. So just a simple sample. How will you go for it? How will you go? How will you go and create the script, right? So this is the first 5-7 lines is like a hard coded. Should not be changed, and you should be changing from where I've written deployment step should be written from here. So you can start creating tables, you can start deploying your you start creating directory in the STFS. So in the same way, you have to write the rollback script as well. Okay. So this is one of the example how we write a stage in Jenkins file. So you can see I've written a deploy stage in which I am using my site.yml file to deploy all the objects in production. So this site.yml is nothing is this. So as you can see in the task, I have written a block. So ultimately it is going and using the forward script. The forward script is nothing. In the config file, it was forward.sh. So if everything goes fine, deployment is happening. And if anything fails in the block, it will go to rescue. So if it goes to rescue, automatically it is calling the rollback script and doing a rollback. Okay. Thank you.
Thank you for covering DevOps for us. Any questions here from the audience? Yes, 1 second.
How much time are you saving some of these teams?
How much time it is?
Are you saving time for these teams? How much?
So it is a continuous integration, because it's saving too much of time, because if everything is tested and fine, then automatically we are moving into production. We don't have to wait for, let's suppose 15 days or something to schedule a CR and then you to go to the high environment, right? So with a continuous deployment, we are saving around maybe from 15 days coming to 3 days or something.
Great, thank you.
Hi, I have a double question. One is how many people are using these pipelines? And the second, is there anybody else that can touch them beside you? Or because in my experience, the complexity of these pipelines comes
Yeah.
to a point that
So the first thing we need to understand that everything is on cloud now. But there are some data which is very sensitive, which like it is made for BT. Means I was working for BT, and some data they don't allow. They say it's too sensitive for that. This pipeline is getting used, and it is getting used for 14 such platforms. When I left the company, it was getting used for 14 such platforms, and because it follows that automatic rollback option, they were very happy to use it because they don't have to just get up at night and solve the issue, because they can come back tomorrow and again they can run it. Let's suppose if I create a CR window of 3 days, I can run it again. So that was the most beneficial and good part, and they were very happy for it. uh,
can anybody else touch
Now they can touch it because I left the company. But yeah, because we had a centralized team. They called it as a Mobius. So they were mainly maintaining it. So if any issues or if they want extra requirement or any enhancement, they will approach to the Mobius team, and they will do the corresponding changes. So it's not like a hard coded code. It's just a sample. And if they come and they say that I want this stage as well, let's suppose, because this is for mainly for big data. Let's suppose they come for Java deployment, so they will use Gradle or something to build it, and they may be using a continuous monitoring tool like Grafana. So they will come and say that, yeah, I want this, and can you just add this stage in it? So we will just adding the stage, and we will made it available to them, and then they will just introduce changes they can do the changes in the config files, and they can run it in their environment.
More questions? Oh, yeah.
Data pipelines and extension. DevOps is a really good base model you showed there, but the artifacts that you're going to be transforming into the DevOps is far greater now. There's dynamic application security testing as well. So have you extended the model? Data pipelines.
So data, see, it's mainly for big data projects. But I will not say that I have done for RDBMS, but I didn't productionize it, but we used Liquibase for it. So it was the best tool I encountered in my 2 years journey of DevOps, where because when I went to DevOps, the deployment of RDBMS was very hard. It is very hard because you have to write everything in Unix. So one of the tool that I found that Liquibase was the best, and it was used by Fidelity Investment that time. And then there was a collaboration, and there was some knowledge transfer from them, and then we thought that we should implement it. So it's not a hard coded. We can extend it, we can reduce it, but it's like it has to be gone by a centralized team. Otherwise, the standards will go like there will be no standards.
Yeah, centralization and control comes with the availability reduction.
Yeah.
So availability versus confidentiality is always a thing. So I'm in the middle of that on security for finance.
Yeah.
So I always get blamed as a guy that slows stuff down. Yeah. So you have to consider the use cases.
Yeah.
And then extend.
So they will approach us with the use cases, and because we have a expertise who can implement different type of tools in the same, because how I write one stage, in the same way other stage can also be written, because it's just a sample of file. Like 20 lines of code I've shown you. It was around 1,000 code. I can't show it here. So if they say that I don't want this stage, we will remove it. If they say we want this stage, we'll add it. So in this way, it was completely customized, and it was like governing around 15-20 teams. The centralized team was governing around 15-20 teams.
Yeah.
So that was the best part, because it was too flexible and feasible for every team.
Thank you.
Yeah.
All right. Oh, one last question then.
Did it take a lot of different iterations to get that combination of bits of software that would work together?
So it's not about iterations, it's about requirements. Let's suppose the same pipeline can be made for different teams, but the stages can differ. So let's suppose you come to me and say that I don't want for big data, I want for RDBMS. So I will remove big data stage, I will introduce RDBMS stage. But the concept, the flow will remain the same. The tools may differ. Maybe you don't want, you said that maybe I can use it for Ansible because we are a centralized system, so we were the responsible for making it a best solution for you. So if let's suppose you come for me for RDBMS, I will say no, you don't need Ansible, you need a Liquibase. So we will go for Liquibase and we will introduce it. It'll give you the pipeline, and then you will do your changes in the config file which I showed you, and you can use it how you want.
Cool.
Well, thank you, and let's give Abhishek another round of applause and thanks. And keep it rolling for all our speakers tonight. To Roland for teaching us how to get started. Take a project and stick to it, and don't bother with Flask if you're headed to Django, right? And Mehmet, for showing us some great stats about trickle-down economics, how GDP and income inequality were unrelated in 3 different countries. The econometrics part of our evening. Andrea, for teaching us a time series analysis and showing us that how the power of ensemble methods and the surprising capability of profit to be the worst and the best time series forecasting model. And to Jinadu for presenting your machine learning natural language processing problem with I'm a big fan of natural language processing myself, and it is such a hot topic now with the large language models. You know, how's that going to affect the development in bag of words? And Felipe, for, well, not only for your awesome graphics, which elevated the slides tonight, but also for showing, you know, connections between, you know, machine learning and neural activity and the fight and flight responses. And then finally, Abhishek, thank you for teaching us about DevOps and, you know, single click deployments and, you know, with your 5 to 7 lines, did you say, of boilerplate, and then you can off to the races with both deployment and rollback, and very happy customers. So again, thanks a lot to those speakers. Thank you for coming out and standing up here and presenting to us. I think, you know, raise your hand if you didn't learn anything tonight. Yeah, that's what I thought. Now, how thirsty are we? Because they're down the road here on London Road. There is a place called Al Campo, and we're headed there. As a core group of regulars, and we'd love to have as many of you with us as possible. So if you just come out with us down the road, Al Campo on your left-hand side, we'll sit down and carry on the conversation. But thank you. That's it for the program. Take care. Bye-bye.